Okay, my dear student, today we will discuss about electronic configuration. Electronic configuration means the arrangement of electrons. It is the arrangement of electrons in an orbital or shell. It is the arrangement of electrons in a particular orbital or shell. This is your electronic configuration. Now, there are certain rules while filling the electrons, we cannot fill the electrons by our own wish. There are certain rules which we have to follow. So first we will know that principles on which electronic configuration based. So principles of electronic configuration, your first principle is Aufbau principle. Aufbau is a German word which means building up. It means building up. What does this principle states? That in the ground state of atom, the orbitals are filled in order of their increasing energies. What does it states? That this rule is also known as N plus L rule. This rule states that the orbitals which are lower in energy are filled first, and the orbital which are higher energy are filled after the lower energy orbital. And N plus rule, how you will calculate the energy with the help of principal quantum number and angular quantum number. Suppose I am taking 3s and 2s. Then which orbital should fill first? First we will calculate their N plus L. N plus L. N for this orbital is 3 and L for this orbital is 0. For this orbital N is 2 and L is 0. So here N plus L comes out to be 2. Here N plus L comes out to be 3. Higher the value of N plus L, more is the energy. So in this case, this orbital 2s will fill first because it is lower in energy than 3s. This is Aufbau principle, which means building up, which states that in the ground state of atom, electrons are filled in order of their increasing energy. Now there might be possibility in which the N plus L is same for both. Like I am taking the example of 4s and 3p. What is the value of N for 4s? It is 4 and L is equal to 0, and N plus L comes out to be 4. Here N is equal to 3 and L is equal to 1. Here also N plus L comes out to be 4. Now, which will fill first? Who will decide whose value of N is less? In this case, N is 3. In this case, N is 4. So, in that case, in which N plus L is same, in that particular case, we will fill that orbital whose N value is less. Okay? Is it clear or any doubt? Any doubt, please let me know. Simple it is. N plus L rule. Okay, bete. Now, second rule on which your configuration depends is Pauli exclusion principle. In an orbital can have the opposite spins. It states that an orbital can have maximum 2 electrons and their spin should be different. Suppose one is moving in the clockwise direction, so other should move in anti-clockwise direction. This principle states that an orbital can have maximum of 2 electrons. Suppose this is the orbital. It can have maximum of 2 electrons and their spin should be different. See, this is correct. This cannot happen. This cannot happen. Their spin should be opposite to each other. Their spin should not be same, which means if one is moving in the clockwise direction, other should move in the anti-clockwise direction. This is your Pauli's exclusion principle. Third rule on which electronic configuration depends is your Hund's rule of maximum multiplicity. Hund's rule of maximum multiplicity. See, this rule states that electron pairing in p, d and f orbital. Why not s? Because s is having single orbital, p is having 3 orbitals, d is having 5 orbitals, and f is having 7 orbitals. So electron pairing in p, d and f orbital do not take place until each orbital is singly occupied. Until each orbital is singly occupied. What does it mean? I am taking the example of p orbital. See, suppose this is your p orbital. P orbital is having 3 orbitals, px, py, pz, and I am having 3 electrons. Suppose in that case I am having 3 electrons. So in that case you have to take all the 3 orbitals in all the 3 electrons in every orbital. This is the correct configuration of representation. If you will do like this, like you start pairing in one and one is left empty. No. You have to make every orbital singly occupied. Pairing do not take place. If we have 4 electrons, then you can pair any orbital like this. But their spin should be different, remember. If you have 5, then it will be like this. If you have 6, then it will be like this. So dear students, these are the 3 rules on which electronic configuration depends. Is there any doubt till now? Please let me know. Or if it is clear, give me thumbs up fast. Right? 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5f, d, 5p, 5s, 6s, 7s, 8s, 6p, 6d, 7p. Now, I will draw some lines in a zigzag manner like the snake moves. It will tell us the energy of orbitals. See, first we will fill the 1s orbital. When it fills, then we move to 2s orbital. When it fills, then we move to p orbital, then 3s, 3p, 4s, 3d, 4p, 5s. Have you seen before 3d, we are filling 4s because when you calculate n plus l for this, for 4s, n plus l is 4, for 3d, n plus l is 5. That's why it is filled first. 4s is filled first, like this. Like in zigzag manner. In the starting, you have to write this. When you start practicing how to write the configuration, then you no need to draw this. Okay? So kindly say it once. After that, I will continue with my topic. Say this. Okay. Now, filling of electrons in an orbital. How to fill the electrons in an orbital? See, electronic configuration of any element can be represented by the general formula NLX, where N is your number of main shell, like 3, 2, 1. L is your number of subshell. X is your number of electrons. It is the general formula for electronic configuration. Like I am writing 1s1, which means its N is 1, L is 0, and it is having 1 electron in it. It is number of electrons, it is number of subshell, it is N. Okay? So please take out your notebooks and start writing with me. You have to write configuration of 1 to 30 elements. 1, 2, 3. Can anybody in the class tell me the atomic number? What? Hydrogen. Anybody in the class know? Anybody in the class tell me? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. After that, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. After that, I will write start writing with me. So hydrogen is having 1 electron. 1 atomic number means 1 electron. So it will go to 1s1 because s orbital can accommodate maximum of 2 electrons. So this is having only 1 electron. In which orbital? 1s. Now helium is having 1s2 and their spin should be different. Now after 1s, we have to fill what? 2s. 1s, 2s. It is completely filled. It will be 1. For beryllium, it will be both 1s and 2s are completely filled. And in that, the electrons must be present in opposite spins. In case of boron, 1s, 2s, and 2p is having 3 orbitals. So it is having only 1 electron. It will move to either px, py, pz. It's up to you. Now I am not filling this. I am filling p. 1. After that, in case of oxygen, 1 pairing will start. Neon is noble gas. That's why its octet is complete. It is up to 2p6. So neon configuration is 1s2, 2s2, 2p6. My dear students, till now, is there any doubt? Please let me know. 3p1, 3p2, 3p3, 3p4, 3p5, 3p6, and remember after that, do not go for 3D. It will be 4s1, 4s2. So up to calcium, the configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. This is the complete configuration of calcium. Now comes to 21 to 30. 21, 22, 23, 24, 5, 6, 7, 8, 9, 30. Symbols are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. How you will remember? Sachin Tendulkar, very crazy man, फिर कोई नई सेंचुरी जमाएगा. I repeat, Sachin Tendulkar, very crazy man, फिर कोई नई सेंचुरी जमाएगा. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Up to 30 elements, you should know the names on tips. Okay. So, in case of scandium, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now there will be entry of 3d. D have max 5 orbitals, so it can accommodate 10 electrons. It will be 3d1, after that 3d2, after that 3d3. Now always remember this case. It is the exceptional case. Similarly, this case, it is the exceptional case. I will tell you the reasons why they are exceptional. In case of 3D, what is the last? 4s2 and 3d4. It should be. But actually, it is one electron from s orbital will jump to one orbital of 3d, and now you can see it is the half-filled configuration. In this, all the orbitals, one electron is present, which is making it half-filled. And you know, half-filled and fully filled configurations are very much stable. So, in this case, the configuration will be 4s1 and 3d5. You definitely did mistake here. And your teacher will 100% ask question from either chromium or copper. So remember, up to 30 elements, there are two exceptions. One is chromium, another one is copper. Okay? Now, what about the manganese? After that, again the electron will go to 4s2, 3d5, 3d6, okay, 3d7, 3d8. Now, again, in this case, it should be this, but this is not the configuration of copper. one electron will move to d orbital and make it fully filled configuration. It is 4s1 and 3d10. So remember, half filled and fully filled configurations are more stable. After that zinc, it will be 4s2, 3d10. So there are two exceptions, up to 30 elements, copper and chromium. Now, if I will ask, write the configuration of copper plus, which means it gain one electron or it lose one electron. I mean, it is cation or anion? Message me fast. Fast. Yes, it is cation. Copper configuration is 4s1, 3d10. My dear student, before the filling of electrons, the energy of 4s is less than 3d. That's why it is filled first. But after the filling of electrons, its energy is more than that 3d. So electron will be added first in this orbital and electron will be first removed from also here. Which means the configuration of copper plus is 3d10. Do not write 4s1, 3d9. This is the wrong. Here 4s is 0, which means all the electrons will be removed from 4s orbital. In case of cuprous ion, if I will talk about cupric ion, in that case it is 3d9. Okay, 4s 0 or only write 3d9. Similarly, in case of, if I will ask chromium plus 2 or chromium plus 2, so you will write 3d4 because one electron will be removed from s and one is removed from d orbital. Now, the half filled and fully filled configurations are more stable in nature. So kindly keep in mind the exceptional cases. Okay. Why they are stable? Because of the symmetrical distribution of electrons. And second concept is exchange energy. What is exchange energy? The electrons with parallel spins present in the degenerate orbitals. Degenerate orbitals are those orbitals whose energy is same. Just a minute. Whose energy is same. Okay. So when we put the electrons in like in degenerate orbitals, they tend to exchange their position. So the energy released during this exchange is called exchange energy. And whenever the configuration is present in half filled or in fully filled orbitals, then the exchange energy is more. That's why these configurations are more stable than the not half filled or fully filled configuration. My dear student, in today's class we have started the topic electronic configuration. Electronic configuration is the arrangement of electrons in an orbital. There are certain principles which we have to follow while filling the electrons. First one was Aufbau principle. Aufbau means N plus L rule. The energy with lower energy will filled first. After that, the energy will higher energy. The electron with higher energy. Second is your Pauli exclusion principle. No two electrons in an orbital can have all the same set of quantum numbers, or The orbital can have maximum of 2 electrons with opposite spin. Rohit, concentrate here. Third one is your Yin's rule of maximum multiplicity. It states that electron pairing in an orbital do not take place until each orbital is singly occupied. Now, after that, we have started the filling of electrons. The general formula for particular atom is NLX. N is orbit number or number of shells. L represents the number of subshells. X represents the number of electrons in a particular orbit or orbital. So, then we have written 1 to 30 atomic number configuration. There are two exceptional cases, copper and chromium. Chromium is half filled and copper is fully filled. I hope is it clear to you all? Still, if you feel any doubt, then please let me know.